All right, so horizontal translations. Remember earlier I said translations are where you move your graph left, right, up, down. So if we're doing horizontal translations, this is simply moving your graph right or left. So we're going to graph each transformation g of x and write the equation for the transformed function. So the same process. Notice that this time it is the inside of the parentheses that changes. It has an x minus 4. This is the argument of the function. Remember our vocabulary word, our input, our argument of the function is changing. So when your argument of the function changes, it's a little bit weird. If it says x minus 4, you're going to do an x plus 4 over here. So every single time when we're going to change our x value, we're going to add 4 to it, even though it says x minus 4 in the arguments of the function, okay? It's the opposite. Let me just, oops, I don't need to zoom in. I just wanted to draw an arrow. Okay, so they're opposites. Just remember that. Okay, and then another thing I want to point out is that this happens inside the argument versus for vertical translations, this happens outside the parentheses, outside of the argument. So, oh man, here, let it load. Okay, I let it load. So when you have horizontal translations, it happens inside the argument. I'm going to write that down actually. Which is inside the parentheses. And it moves your graph left or right. And then if you have a vertical translation, this happens outside the argument, which means outside the parentheses. And that moves it up and down. Okay, so now let's continue. So let's change our points. So 0, 1 is an original point on 2 to the power of x. Remember, 2 to the power of x originally looks like that, okay? Something like that. So 0, 1 is on the original equation f of x, and we're going to change it by doing 0 plus 4, comma 1. So in this case, our y is not changing. Because we are doing a horizontal translation, the only thing that changes is the x value, because the x values are the ones that go left and right on our graph. So the x value changes for horizontal translations. And you know it's a horizontal translation because it happens inside the argument right next to the x, okay? Okay, so we got 0 plus 4, comma 1, that becomes 4, comma 1. Next point, 1, comma 2. So your x changes. It's 1 plus 4, and then the y stays the same. So this y stays as a 2. We get 5, comma 2. Last one, our x changes. So instead of a 2, we go 2 plus 4, and the y stays the same. The x is changing for horizontal translations. And we get 6, 4 as our final point. So let's graph this out. 4, comma 1, that's right over here. 5, comma 2, 6, comma 4. So I got my 3 dots laid out, but let's pretend I don't know how this will look. Like I don't know where my asymptote is. So let's write out our equation, and then we can write out our asymptote, and then we can graph the rest. So to write out our equation, we have g of x is equal to f of x minus 4. So it's a little bit strange, but let me show you here. So f of x is supposed to be just, here, let me write it up here. F of x is supposed to be 2 to the power of x, right? But g of x is supposed to be f of x minus 4. We're changing the x into x minus 4. We're changing the argument, the input, changing the x value. So it's now 2 to the power of x minus 4. So where there was originally an x, just like f of x, 2 to the power of x, now it's f of x minus 4. So it's 2 to the power of x minus 4. Okay, And then remember that the asymptote is supposed to be the number added or subtracted at the end, but there's nothing added or subtracted at the end except for an invisible 0. So that must mean the horizontal asymptote is y is equal to 0. So it's this number 0 that gets to be our asymptote. So that's not really quite at 0. Let me do that again. There we go. So let me draw my horizontal asymptote at x equals or y equals 0. There it is. And so that is a line that I cannot go below. I cannot cross it. Just going to get really close to it, but never cross it. And so that's what my graph's going to look like. So notice that my graph moved to the right 4. Okay, so when your g of x says f of x minus 4, when you're subtracting, this goes to the right. So if it says x minus 4, you move to the right. Okay, let's take a look at the next problem. It says f of x plus 2. So if we're adding, remember it's the opposite. We're actually going to go to the left, okay? This one's going to go to the left. And then when we write it out as our points, remember that if it says plus 2, then this one should say x minus 2, and the y remains unchanged. Remember that these are opposites. Okay? So let's fill in the t-table. Actually, I want you guys to pause the video and try it on your own. Try to fill out this t-table. Okay, so hopefully you tried it out. Let's just double check your answers. So this one should be 0 minus 2, comma 1, which gives you negative 2, comma 1. This one should be 1 minus 2, comma 3, which gives you negative 1, 3. This one should be 2 minus 2, comma 9, which should give you 0, 9. Okay, and then I'm going to plot those points, negative 2, comma 1, negative 1, comma 3, 0, comma 9. And then I'm going to rewrite this equation. Actually, I want you to try to rewrite this equation. So we know that f of x is 3 to the power of x. G of x should be 3 to the power of what? So try to do that part on your own. Pause the video and then we'll check your answers. Okay, so you're unpaused now. Let's see if you got it right. If you got it right, great, good job. If you got it wrong, that's okay. So it should say x plus 2. And why is that? Well, the x changed to x plus 2. So this x should change to x plus 2 as well. So g of x is equal to 3 to the power of x plus 2. And so what do you think our horizontal asymptote should be? What number is added or subtracted at the end? Hopefully you said 0. So your horizontal asymptote should be 0. So let me draw that in. Okay, and then now that it's drawn in, I can complete my graph more accurately. And so remember, you don't want your graph to touch your asymptote, you just want it to get really close, okay? And that's it for these examples. Let's go on to the next video for horizontal reflections.